Hello everyone. Today we are going to discuss about the moment of inertia in properties of surfaces in engineering mechanics. First of all, we want to discuss the problem. Find the moment of inertia of a T section of flange 100 mm into 30 mm at a web 20 mm into 80 mm about its central axis. This is a given T section. In T section, this component is called one. This component is called flange. So flange component is denoted as the first component. This portion is called the web. This is the second component. The flange distance they are given. Its horizontal distance is 100 mm. Its height is 30 mm. The second component height is 80 mm. Breadth, horizontal distance is 20 mm. Okay. In this T section, we consider the x-axis and the y-axis. Here, y-axis, the given T section is symmetrical to the y-axis. So, due to y-axis symmetry, we can easily find the x bar value. Here, x bar means centroid about x-axis. Due to y-axis symmetry, so we can easily find the x bar. So, x bar equal to maximum horizontal distance of the component divided by 2. In this component, the maximum horizontal distance is 100. So x bar equal to maximum horizontal distance 100 divided by 2 equal to 50 mm. Okay, we can easily found the x bar value. Next, we have to find the y bar value. Here, x bar is centroid about the x axis. Y bar is centroid about the y axis. Okay, next we have to find the y bar value. Y bar value means centroid about y axis. So for y bar purpose, we have to consider the first component, first portion. This is called flange. Its horizontal distance is 100 mm. Its vertical distance is 30 mm. Okay, the first portion is like a rectangle shape. So we know the formula for rectangle, length into breadth. So length is 100, breadth distance is 30. So the 100 into 30, area of the rectangle. So it's denoted as A1. So A1 is equal to 3000 mm square. Next, we have to find out Y1. Y1 is nothing but the Y1 is called the maximum vertical distance of the given component. Okay, here this is a component one. So its maximum vertical distance Y1 is its vertical distance divided by 2. Okay, first component vertical distance is 30 divided by 2. But the first component is placed on the second component. The second component height is 80 mm. Okay, the first component is on the second component. So we have to add the first component vertical distance. So first component vertical distance is 80 mm. So 80 plus the second. This is called web component. The web component. The web component vertical distance is 80 mm. We have to add this value 80 plus, and the first component is on the second component. So first component vertical distance is 30. So 80 plus 30 divided by 2. So finally we got y1 value 95 mm. The same way we have to find the second component. The second component area is denoted A2. Second component also like a rectangle. So its length is 20 mm. Its breadth is 80 mm. So we know the formula for the area of rectangle, length into the here length value 20, breadth value 80. So finally A2 is equal to 1600 mm square. Here we have to find the maximum vertical distance. The second component means it's denoted as y2. Its vertical distance is 80 mm. So 80 divided by 2. So 80 divided by 2 means y2 equal to 40 mm. So we know the formula for centroid. In this problem, only two sections are there. So we find the A1, Y1, A2, Y2. So we the final formula Y bar centroid about YY axis equal to A1, Y1 plus A2, Y2 divided by A1 plus A2. So we have to substitute all the values to this formula. Here A1 value 3000 into Y1 value 95 plus A2 value 1600 into Y2 value 40 divided by A1 value. A1 value 3000 plus A2 value 1600. Finally, we simplify these steps. Finally, we calculate this value. We got y bar equal to 75.87 mm. This is a centroid about y axis equal to 75.87 mm. Here, centroid about the x-axis is 50 mm, and centroid about y-axis is 75.87 mm. Next, we have to find the moment of inertia. Okay, in moment of inertia, we have to find the x-axis and the y-axis. First of all, we have to find the moment of inertia about the x-axis. Here two components are there, so we have to find the two moment of inertia. This is a component one, this is a component two. So first component moment of inertia about x-axis denoted as Ixx1. Second component moment of inertia about x-axis denoted as Ixx2. So first we have to find the Ix1. First component moment of inertia about x-axis. So it's formula Ixx1 equal to Ig1 plus area of the component into H1 bar square. Okay. Here Ig1 means it's a rectangular component. Okay, it's a rectangular component. So rectangular component about x-axis for formula Ig1 equal to it's nothing but it is BH cube. Here formula Ig1. Here we have to find the Ig1. Ig1 formula BH cube divided by 12. Okay, BH cube divided by 12. Here first component breadth value is 100. So 100 height equal to 30. So 30. 100 into 30 divided by 30 power cube. Okay, breadth, here breadth distance 100, height distance 30. So formula BH cube divided by 12. So BH cube divided by 12 means breadth base distance is breadth distance is 100, height 30, 30 power cube divided by 12 plus area of the component length into breadth 100 into 30 in the H1 bar. Here H1 bar is nothing but H1 bar is y bar minus y1. Here we know y bar value. Y bar value 75.87 mm. Here already we know the y1 value 95 mm. So we substitute the value here. Here H1 bar equal to first of all we have in this step we have to substitute the major value and then we have to substitute the and then we have to subtract the minor value. Here the major value is 95 minus the minor value is 75.87. Finally, H1 bar equal to 19.13. In this value, we have to substitute here. So Ixx1 equal to the 100 into 30 power cube divided by 12 plus area of the rectangle 100 into 30 into H1 bar value 19.13 whole square. Finally, we have to simplify this step. Ixx1 mean first component moment of inertia about the first component about x-axis equal to 1.323 into 10 to the power 6 mm power 4. The unit for moment of inertia equal to mm power 4. Okay. Similarly, we have to find the second component moment of inertia about x-axis. So second component moment of inertia about x-axis formula Ixx2 equal to Ig2 plus area 2 into H2 bar. Here, second component Ig2 formula. Its second this is the second component. This is the web. Its height is 80 mm. Height is 80 mm. Breadth is 30. Breadth is 20 mm. So we have to substitute here. Breadth distance 20. Height is equal to 80. 80 power cube divided by 12 plus area of the component 20 into 80 plus H2 bar. Here H2 also same procedure. H2 formula we have to substitute y bar minus y2. Here y bar value we know y bar value 75.87 minus y2 value we find y2 equal to 40. So we substitute the formula here. Here H2 bar equal to okay, in this step we have to substitute the H2 bar value. Okay, finally we substitute all the values. Here the H2 bar value equal to 35.87. Okay, because H2 bar equal to y bar value we know y bar value 75.87 minus y2 value what 40. So finally we got H2 bar equal to 35.87. So all the values substitute to this formula. Here Ig2 is equal to BH cube divided by 12. Here breadth distance, here breadth distance is 20, height equal to 80, so 80 power cube divided by 2 plus area of the common length into the okay. Here the breadth distance is 20, height is equal to 80, so 20 into 80 plus H2 bar value is equal to 35.87 whole square. Finally, we simplify this step. Ixx2 second component moment of inertia equal to 2.9111 into 10 to the power 6 mm over 4. So second component moment of inertia about x-axis equal to 2.911 into 10 to the power 6 mm over 4. So finally, the total moment of inertia about x-axis equal to first component moment of inertia about x-axis plus second component moment of inertia about x-axis. So we have to substitute the values. We have to add the two values. Here the first component moment of inertia about x-axis value is 1.323 into 10 to the power 6. Plus the second component moment of inertia about x-axis is 2.911 into 10 to the power 6. So finally, the moment of inertia about x-axis of the given t section equal to is Ixx equal to 4.234 into 10 to the power 6 unit is m power 4. Okay, this is a moment of inertia about x-axis of the given t section 4.234 into 10 to the power 6 m power 4. Okay, next we have to find the moment of inertia about y-axis. Y-axis, the same procedure we have to follow. Here two components are there. So Iyy equal to Iyy, first component moment of inertia about y-axis, second component moment of inertia about y-axis. So first we have to find the first component moment of inertia about y-axis. So Iyy1 equal to Ig1 plus A1 H1 bar square. The same procedure we are follow. Here Ig moment here about y-axis Ig value is here formula we have to change HB cube divided by 12. In this step, we have to substitute HB cube divided by 12. Okay, the same procedure. This is the first component. Okay, it's the breadth distance is 100, height distance is 30. So formula is called formula Ig1 equal to about y axis equal to HB cube divided by 12. Okay, here height 30, breadth distance is 100, so 100 power cube divided by 12. So here area already we know A1 value already we find. Here A1 value is common. A1 is 3000 mm square. Next we have to find the H1 bar. Okay, same procedure we have follow. About y axis H1 bar equal to x bar minus x1. Here x bar value 50, x1 value also 50. So H1 value H1 bar equal to 50 minus 50 is 0. So here substitute here A1 is 0, 0 into anything 0. Therefore, Iyy1 equal to Ig1. So Ig1 value is HB cube divided by 12. Here height is 30, into breadth value 100. So 30 into 100 power cube divided by 12. This is a first component moment of inertia about y-axis. This value is 2.5 into 10 to the power 6 m over 4. Next, we have to find the moment of inertia about the y-axis of the second component. Here, Iyy2 equal to second component moment of inertia about y-axis equal to Ig2 plus A2 H2 bar whole square. Here, H2 bar also 0 because H2 bar equal to x bar minus x2. Here, x bar equal to x2. X bar value equal to 50 means x2 value also 50. So 50 minus 50 is 0. Here x2, H2 bar value 0. So 0 into anything 0. Therefore, Iyy2 means moment of inertia about y-axis of the second component equal to Ig2. Here the same formula we are substitute. Here formula is HB cube divided by 12. This is the second component. This is the height of the second component 80 mm. This is the base distance 20 mm. Here height HB cube, H means 80. Breadth distance is 20. So 20 power cube divided by 12. So finally we got moment of inertia about y-axis of the second component is 5.33 into 10 to the power 4 mm power 4. Finally we have to add the two components moment of inertia. So Iyy equal to Iyy1 1 plus Iyy2 means first component moment of inertia about y-axis, second plus second component moment of inertia about y-axis. So we add this value. Finally, we got moment of inertia about y-axis equal to 2.553 into 10 to the power 6 mm power 4. This is a final output. Okay. In this problem, they have to ask to find the moment of inertia of the x-axis 4.233 to 10 to the power 6 mm power 4, and the moment of inertia about y-axis is 2.553 into 10 to the power 6 into mm power 4. This is the final output. In additionally, we have to find the polar moment of inertia. Polar moment of inertia is nothing but it is the sum of moment of inertia about the x-axis and sum of moment of inertia. It's the sum of moment of inertia about x-axis and the sum of moment of inertia of the y-axis. Okay, here the polar moment of inertia is denoted as IP. So IP equal to Ixx plus Iyy. This is the moment of inertia about x-axis. This is the moment of inertia about y-axis. So we have to add both values. We easily find the polar moment of inertia. Here the Ixx value equal to 4.233 into 10 to the power 6 plus Iyy value 2.553 into 10 to the power 6. Finally, we have to find the polar moment of inertia equal to 6.786 into 10 to the power 6 mm power 4. Okay, this is the final output of the given problem. Okay. Okay, this is a moment of inertia about the x-axis. This is a moment of inertia about the y-axis. This is a polar moment of the given t section. Thank you. Next class we will discuss the next problem. Thank you. Thank you to all.